Hi, welcome to another Tuts episode. In this episode we are going to cover the usage of domains and how that can help make your Node.js application server resilient and manageable on the event of errors. Before domains were introduced in Node version 0.8, the life of a Node.js server was much harder. Whenever an error was thrown, the node process would log the error and exit. Let's see what happened there. I'm going to create here a new server.js file. And let's create an HTTP server here. So let's say here we have an object A, a variable A that we forgot to initialize. And then we try to call a method on that variable. And then we end saying thank you for using our service. And then we make the server listen. Let's see how well that goes. Oops, so the server died because of an error. So in this example we are forcing an error to be thrown when processing any request. But this type of error can happen occasionally, bringing your entire server down, and with your server all the clients that were connected to it. So to prevent Node.js from exiting, we could listen for the uncaught exception event on a global process object. Let's see how you could do this. Okay, so let's see how this server behaves. So we got here an uncaught exception, but as you can see, our request is still hanging. So this prevents your node process from going down, but leaves you with a resource leak, which in this case is an open connection to the client request and an unresponded request. So the most responsible thing to do in this case is the default thing, which is to log the error and exit the process. Here you can take the opportunity to make a graceful shutdown, but you still have to shut down because you're in an unknown state. All the event types are equal to an event emitter with one exception, which is the error event. So if an error event happens, if it's not handled, has a similar effect to an uncaught exception. Let's see what happens when an event emitter emits an error event. So let's remove this process uncaught exception here, and let's create an event emitter of our own. So on when a request happens, let's emit a random event and then let's emit an error event. So let's see what happens here. poof, your server went down. So here we instantiated a new event emitter just to make it mimic what happens, for instance, when you do an HTTP request or any other kind of operation that might fail on an event emitter. Here you can see that we're emitting the example event, and that does not pose a problem, but the error event originates an uncaught exception which terminates the process. So without using domains, the best way to handle this is to listen for the error event, which prevents the uncaught exception for being thrown. So here we will add an error handle. So as I was saying, we're using here an error handler, and then we can take the opportunity to report the error to the client and end the response. So we can say, for instance, write head the 500 error status and end with, for instance, the error message. So this will propagate the error to the client. Anyway, if before that an error is thrown into the stack, we are still left with an uncaught exception. Domains, which were introduced in Node version 0.8, come to solve these types of problems of error handling. So using a domain, you can channel all the errors happening in the context of that domain through a single object. Domains propagate across event emitters, so when an event emitter is constructed, it inherits the current domain. And when an event emitter emits, that domain is entered. So here is how you can use domains in our previous server. So let's first require the Node.js core, domain module, and then here the first thing we do here is create a new domain when there is a new request. And put some error handling here. So once there's an error or on an error, we can do something like say 500 error status. I mean, I can just copy this. Okay. Remove this error handling here. So, and then we run. So we run all the codes belonging to a domain inside this run the run scope, and then the domain knows what to do when an exception is thrown here or when there is an event emitter that is constructed here. Let's see how that goes. So yes, what happened here is that the event emitter somehow got associated with the current domain, and when we emitted an error, that error got propagated to the domain and not to an uncaught exception on the process. So besides binding event emitters, it can also catch errors thrown in the run context. So for instance, we had that variable a here, we can, for instance, try and call a.abc, something that does not exist because this object is undefined. and let's see what happens here. So yeah, the server did not die, and the client connection was terminated with a 500 error saying the error message. This also works if the error is thrown asynchronously. For instance, we can, for instance, do a like set timeout. All the timers support domains, so let's see how set a timeout in half a second, for instance. Okay, so that also worked. We saw how event emitters are explicitly added to a domain if they run in the context of a domain. If you don't have a domain set up when the event emitter is created, you can explicitly add event emitters to a domain like this. So for instance, we want, after the domain is created, you want to add request and response objects, which are also event emitters that can emit errors. So you can add request, add response. And just one thing is that adding this these emitters increases the chance that we get an error when we do something on a response like this. So you could get into a loop that we try to write something and we get an error, and we try, then this callback enters again and we get an error, and then we exhaust the stack and Node.js explodes. So we're here, you can put a simple safeguard and say replied equals false, and so if not replied, we can say replied equals true, and else do something, for instance log the error. So let's test this again. Okay, so that worked. So we added the domain. So let's try and emit the error on the, I can say like response.emit error, new error, help. So here it goes. Oops, sorry. So typo here, error, help. Besides event emitters, I/O is also processed in the context of callbacks. Domains also support the standard callback pattern. For instance, if you're reading a file entirely into memory, you're using the callback pattern. So let's do that. So here we do fs.read file. Let's read the source file, and then provide a function with an error. So here, typically, you have to say if error, and then, for instance, you throw error. Otherwise, we end the response with content, the file contents. So just to prove that works, you get the file contents here. But so let's provoke an error thrown here. So we get the error caught, but you still have to handle this error right? So we can automatically do that without having to throw anything into the domain by using domain.intercept, and then we pass a callback that does not contain the callback, the error argument. So what this does is that it will intercept the callback. If there is an error, it will propagate the error into the domain. If not, it strips out the first argument, which is the error which would have been empty, null, or undefined, and then passes the remaining arguments to this callback function, which we can just assume here that we have a successful read file. So, sorry. Okay, so we replied. So we did this res.end and it worked. So this concludes the episode for today about error handling in Node.js and using domains. Thank you for watching and see you soon. Bye bye.